What up? Back at it again with some Socio development. We got 2 updates in one video this time, because lazy efficiency, we all love that. Both versions don't really change much, except for 0.8, which just absolutely destroys backwards compatibility because I thought it was fun. And then 0.9, which just basically adds progress bars, which is pretty cool. As for 0.8, you will notice here in the full stack framework demo that all of these Socio strings are now preceded with Socio, as opposed to post pending a comment called Socio or whatever. This is done with some absolute JavaScript magic that I absolutely love. The template string literal tag functions. So this is a tag function. So that means you must always use these this specific string literal notation. This won't work and this won't work. And then you must absolutely put this Socio function in front of it. You don't need this exact function, you just need any function that says Socio in front of it. So you can make up your own, or you can import one from utils. And this marker is no longer needed. I think you can still add it if you want, but it won't do anything. However, you do still use auth. My U key doesn't work. You still write something like this, like auth and perm, so that's still a thing. The reason for doing this is pretty much the regex parsing thing, because regex loves to parse from left to right, and making it do this amount of lookbacks was incredibly difficult. Even rewriting it like 3 or 4 times. This is for the Socio security class, so that it can do its thing. You can find these strings in the source code, and this was just the simplest way via suggestion on GitHub. So now we're doing this. This tag function actually does work. It's fully implemented, but when the string gets replaced here during the parsing with its encrypted version, it'll basically get rid of this thing, so that doesn't matter. It's never going to run, and then this is going to become that long encrypted thing. So you don't need to worry about extra function calling overhead. So now we can take a look at the progress bars of version 0.9. If I press this start button, it's actually going to run an SQL query here, encrypted, of course. And you can see this bar filled up. Now it filled up very quickly because this query is like 73 bytes or whatever. However, this is much more useful for files. So if I select a 17 megabyte file, and you can see that bar fill up, and we can see that everything worked out as a success. Note that I did actually slow down the browser's transmit rate. Otherwise, well, localhost is so fast that this just jumps to the end and you wouldn't be able to see the bar fill up. So now prepare for PTSD, because we're going to look at some punch card code. Here you can see how the run query, that's the start button, what it does. Pretty much the same thing as before. You just called, query. You just called the query function. Give it your SQL, again with the and then you're not going to await that, and that's going to result in getting a promise of what the result is going to be. If you do like before, because you can, because this time I actually did preserve backwards compatibility, you will see that Q is no longer a promise, which means you can't track it anymore. If it's no longer a promise, if you've awaited it, then there's nothing to track, of course. So instead, you don't await it. You actually choose to save down the promise, and then, so instead you use this promise with this function here that will set up a timer on an interval, and it will report back to you on your update callback the percentage of the progress from 0 to 100. So here I'm just setting the callback to be equal to some kind of local variable progress, and then I'm displaying the progress in literally the progress HTML tag. And then you can also supply the frequency milliseconds. By default it does 30 frames per second, so that's like 33.34 milliseconds or whatever. In case your app happens to be very intensive, then you can lower or raise that value if you need more precision on the progress bar, whatever. And then at some later point, you can await this promise, or you don't even have to await it. The tracker will work anyway. Also, you can get the interval ID from here. That's what it returns. It says Node.js timer. I don't know why, but you can use this basically to, at any time, clear interval. You just pass that in there and it'll clear it. So in case there are like errors or something and you want to destroy that timer. Otherwise it will tear down itself when it reaches 100%. For the upload files, the same thing happens. Instead of how you would normally await, as it is in the docs, send files, you again just want to get that promise that's going to resolve to, for example, the result. You pass that promise again to the same function, and you can track the progress of it, and it's nice and neat, and you can await the success. However, I also kept in mind that a lot of you will most likely want to use Svelte, because if you don't, you should. So I made sure that this works very nicely with Svelte stores, the native stores in here. So if I import writable from stores, then prog is now a store, which means I can use nice syntax in Svelte. And so here, instead of this, I can do prog.set as the callback function, and this will just pass that percentage in there. You can take a look at the documentation. Here's a new entry, just more comments about how to use this. Note that this actually is very hacky, and it's only an approximation, so it is definitely not precise. Unexpected things can happen. For example, like your percentage can even run backwards sometimes. I have not observed this, but I'm pretty sure it's possible. This is because the WebSocket protocol spec doesn't actually give any kind of mechanism to track individual requests' progress. However, it does give you access to the send buffer. And so me doing a bunch of clever maths and at very specific points in logic, writing down some values, I am able to track each request on its own in the buffer of where it might sit within a byte range. And then I just check when those bytes have been sent out, which is incredibly imprecise. This can all go very wrong, even if you have some like delay here between the actual promise being set up and this tracker being set up. The bigger the delay here, the less likely this is to ever actually reach 100%, or it'll just do so later and report incorrectly, because I'm just only tracking bytes exiting a buffer, which is like almost no information at all to work with, but it's the best that I could do. In addition, if you need some assurance of using Socio, if you like to live on the edge like a real JavaScript dev, then here's actually one of my personal websites that is currently using Socio in production and is showing real-time data of the real estate market in my city, which I think is pretty cool, and it's one of a very good use of Socio because this data is real time, so these graphs update real time. So basically Socio should be production ready, and I've deployed it here and I've put my trust on the whole database on my server. I think it's safe. And tune in next time where I upload my brain to ChatGPT 5.